Hey, hi guys, welcome to my channel. Today is the sixth session of NumPy. I understand it has already been six sessions because there is so much to this library that there is always a temptation to show as much as I can. So today we'll be discussing some of the mathematical operations between NumPy arrays and how can we join two arrays or merge two arrays to create larger data space, right? Because this small concept will help you in understanding how we deal with bigger data frames. So first we import NumPy as NP. Let's say I have two arrays. B is equal to np.arrange of 10 to 15, right? So my A is this, my B is this. So if I do A plus B, does it happen? So we have how many values here? 1, 2, 3, 4. 4 values, and here there are 15. Well, 4 values, and here there are 5 values, right? So it won't be able to add. But if I make it 11, it has given me the addition of element-wise addition, right? So if you look at this, when we have 4 elements in one array and 4 elements, the same number of elements in the other array, then only we can do addition. If we have unequal number of elements in both the arrays, we will not be able to add them. Because in matrices also, if you remember, when you do addition, it happens element-wise. So 11 will be added to 1, 12 to 2, 13 to 3, 14 to 4. 0th index, first index, second index, third index. Now, if you do a B minus A, will it work? Yes, it does. We have the differences everywhere, 10. Now, what if we do A into B? How much do I get? It is an element-wise again. It is element-wise, right? Now, can I do A divided by B? Same thing. Or let me do B divided by A, same way. You can make that happen. Unless and until the point you have the same number of elements in both the arrays. Now, can we have a two-dimensional array? Let's say array of small example 1, 2, 3, or I can again use some kind of automation, right? List of range of say 1 to 8, okay, or 1 to 7, let it 1 to 7, and then you can close this list here itself, and again do list of, I have to keep the same number of elements, of course, right? So if I make it 2 to 8, or let's say again 11 to, right? This is a 2D array, okay? And similarly, let me make one more array here. Let me call this again as B. Or let me call this as C, and this as D. 111, 117. Let me add, say, yes, let me make it same, no problem, right? And just to run the cells again, I'll just do run all from above. Right? I have this two arrays. Now, if I do C plus D here, will this work? Yes, it does. Again, it happens element-wise because the shape is the same. Can I do C minus D? Yes. C divided by D? Yes. C into D? Yes, no problem. But if I have unequal dimensions, let's say I have another array, let it be, say, E. And let me make this slightly tougher, okay? Let me make it one element is extra in the second list, right? Now, can I do D plus E? See, operand could not be broadcast together with the shapes 2 cross 6 and 2 and comma, because this has not been treated as a 2 cross 2 cross 6 matrix. It has been treated as a 2 cross 1 matrix because of this extra element which you see here. It has taken this entire list as just one element. That's it. Okay, so whenever you do any kind of array computations, the shape has to match. The number of rows, number of columns has to match. Okay, so let us look at again A, B, right? We had C and we had D, right? So C into D was indeed possible. Now there is one more function in arrays, let's NumPy especially, C dot D. What does it show now? It shows shapes 2 cross 6 and 2 cross 6 it's not possible because They are not aligned. It is saying they're not aligned. Now remember in matrix multiplications, dot product, cross product, all those things we had already done in physics as well. Simple multiplication requires the shape to be same. 2 cross 6, 2 cross 6. But as soon as you do a dot product works in a different way. It will require that if this is m cross n size, it has to be multiplied by a matrix where it starts with n. So the last dimension of the previous matrix has to match with the first dimension of the second matrix. So number of columns here, the number of columns has to be equal to the number of rows of the second matrix. So it can be anything, n cross, Tom, Dick, and Harry, whatever it is, doesn't matter. But these two has to match for the multiplication to work out, because this happens not element wise, but every row multiplied by every column. That is how it happens. We already know about it in matrix 101. So let me now twist it. So how will I twist it? Now I need 2 cross 6 into 6 cross something, right? Can I do C dot dot of, instead of D, I'll do D dot reshape of C is 2 cross 6, so I'll make it 6 cross 2. Now this has worked. So what happens? So when you have an m cross n into n cross a, my output resultant is always m cross a. So these two gets cancelled out. So here what has happened? We had a 2 cross 6 matrix. We had a 6 cross 2 with us. So sorry, 2 cross 6 again, second matrix. To make the dot product possible, I reshaped it to 6 cross 2, the second matrix, right? Now 6 has matched, 6 has gone away, and now what it remains is 2 cross 2. That is what exactly I have gone there. Now these two may not be same. It can be 2 cross 6 into 6 cross 3 also. If I make it 3 cross 4, again, it will not match. Okay, let's again take an example. Let's say we have another, let us generate some values, easier to do. Let me pick it as 1, comma, say 5. 4 elements here, 6, 7, 8, 9, 10. Okay, let me make it as F. And again, I'll create one more element. Let's say G. So this is 2 cross 4. So I have to make this as 4, which is already there. And this I can make anything. So let me make it 4 cross 6 cross 615. Right. Oh, but the number of elements again has to be same. So of course, if there are 4 elements here, I have to make 4 elements here. Otherwise, I will not be able to create that array, right? Now, if I do F into G, this will work out fine, no problem. But if I want to do dot product, I have to do G dot reshape. G dot reshape of what? The reverse, right? Just 2 cross 4. We may make it 4 cross. Finally, I get a 2 cross 2 matrix. So this is how it works. Now I can increase one more dimension here. So what I'll do here is I'll put one more list here and I'll make this as 21:25. Now I have 3 rows, right? So it's a 3 cross 4 matrix, right? Now M into G is not possible because both dimensions do not match. But however, if I do G dot reshape, now I have 3 cross 4, I'll make this 4 cross 3. And the resultant will be 2 cross 3. And if I do this as dot shape, I'll get 2 cross 3. Both of these do not need to match, but the number of columns from the first matrix has to be equal to the number of rows in the second matrix. So this is how dot product works. So now let us say we had 2 arrays, right? C and D. Both of them, the size is same, 2 cross 6 and 2 cross 6, right? Okay, now can I concatenate the information? Can I do something like np.concatenate? I forgot the function. No problem. I can, if I just see here, shift tab, it is working, which means that the function is correct. So if I do C comma D, what has happened here? It has joined the arrays row wise. See, on this has been added below this array, right? Because these two have come from below. Whereas if I do this and comma axis is equal to 1, what has happened here? Now this has been added on the side of the, on the right hand side of the previous array. So this joining, such joining is called as column-wise joining because you're adding more columns to it. However, this is called as row-wise joining because we're adding more rows to it. So there are two kinds of joining which you can do. One top of the other, which is called as row-wise combinations, or one side by stacking, which is called as column-wise additive, column-wise joining. And this axis is equal to 1 basically means you are trying to tell the machine that to add it or to join it, not add it, but join it column-wise. So by default, this axis is actually equal to 0. This is a default. So we don't need to put it. We don't put it by default, it means row-wise. So this is actually row-wise. And this is column-wise. The same simple concept will be used in data frames also, where you have two different information from two different data frames. Based on the information given, you will add it column-wise. Suppose I'll give you an information. I'll give you an example. Say you have two data frames, okay? Both of them have the same number of columns, same information, but more numbers. Suppose this is name and salary, and this is name and salary. Okay, here you have bunch of names from a sales department. Here's a bunch of names from the product department. So if I want to have the information from both the departments, will you join it column-wise? No, I'll join it row-wise because the number of columns is same. However, if I have say information of say name and salary, and also here name and some other information which department it belongs to, or some other information, right? Where he stays, what's his phone number, whatever it is. Then will I add it row-wise? No, because the number of column, the column names are different. And here we have the name column. Here also we have a name column. So we'll try to join them based on some information, based on a name column. Let's say we have one more function called stack. Okay, so if I do stack of C, D, you can see here, it has not added row-wise. Please be very careful. Here the dimension has changed. Number of dimension is 2. Yes, the shape has changed. It can be 3 cross 4, it can be 2 cross 6, whatever it is. But the dimension has remained the same in both these cases. This is actually 3-dimensional because we have one more list outside, right? So what's the shape here? Let's see. 2 cross 2 cross 6. So similarly, you have vertical stacking, horizontal stacking. You know, if I do np dot h stack of C, D, so it will add it. So it's same as concatenate column-wise. You have vertical stacking, same as concatenate row-wise, because when you do row-wise, the number of rows increase, right? That is why it is called as vertical stacking. Same as concatenate. So this is same as concatenate x is equal to 0. This is same as concatenate x is equal to. That is all for today, guys. Got a lot of information. I hope this has helped you in learning more concepts about arrays and how do they work. This will lay the foundation for further understanding linear algebra if you wish to. But these are small techniques or concepts which anyone can use from any domain to work with data. So thank you so much, guys. I hope you have enjoyed today's video. If you have, please like, share, and subscribe to my channel. We'll bring you more and more interesting videos every day. Thank you.